Welcome to our Electromagnetic Compatibility (EMC) tutorial. In this comprehensive guide, we'll embark on a journey to explore the fascinating world of EMC, a critical field in the design and functioning of modern electronic systems. EMC is the branch of electrical engineering that deals with the unintentional generation, propagation, and reception of electromagnetic energy. Understanding EMC is essential to ensure that electronic devices operate as intended, without causing or suffering from electromagnetic interference, EMI. This interference can disrupt the functionality of devices, leading to a range of issues from minor annoyances to critical system failures. Throughout this tutorial, we will delve into the core principles of EMC, starting from the basic concepts of electromagnetic fields and their behavior, to the more complex aspects of designing for EMC compliance. Our focus will range from understanding the sources and effects of EMI to the best practices in mitigating its impact on electronic devices. You will learn about various EMC standards and testing procedures, gaining insight into how products are tested and certified for EMC compliance. We will also explore practical strategies for integrating EMC considerations into product design, ensuring that your electronic products not only meet regulatory requirements, but also exhibit superior performance and reliability. Whether you are an engineer, a technical professional, or simply an enthusiast looking to deepen your understanding of electromagnetic compatibility, this tutorial is designed to equip you with the knowledge and skills you need in this ever-evolving field. So, let's get started on this exciting journey into the world of electromagnetic compatibility. Chapter 1: Fundamentals. Basic principles of EMC. Electromagnetic compatibility, EMC, refers to the ability of an electronic device to function properly in its electromagnetic environment without excessively interfering with other devices. The basic principles of EMC revolve around two key aspects: emission and immunity. Emission is the generation of electromagnetic energy, whether intentional or unintentional, by a device. Immunity, on the other hand, is the ability of a device to operate correctly in the presence of electromagnetic interference, EMI. Understanding these principles is crucial for designing electronics that coexist harmoniously in the increasingly crowded electromagnetic spectrum. Legal regulations and standards. Legal regulations and standards in EMC are critical to ensure that electronic products are safe and do not interfere with each other's functioning. These regulations vary by region and country, but they generally set limits on electromagnetic emissions from devices and establish minimum immunity requirements. Key international standards include the International Electrotechnical Commission, IEC, 61000 series, and the European norm, EN, 55000 series, among others. In the United States, the Federal Communications Commission, FCC, regulates EMC for consumer electronics. Compliance with these standards is mandatory for selling electronic products in most markets, making them a fundamental aspect of product design and testing. Methods to ensure EMC. Ensuring EMC in electronic products involves a variety of methods and practices. Design considerations play a pivotal role, including the use of shielding to block unwanted electromagnetic waves, filtering to prevent specific frequency ranges, and grounding to reduce interference. Additionally, product design should account for potential EMI sources and paths of interference. Regular EMC testing is crucial, including both emissions testing and immunity testing, to ensure compliance with relevant standards. Finally, staying updated with the latest EMC standards and continuously improving design and testing processes are key to maintaining EMC compliance. Basic principles of EMC. Electromagnetic interference, EMI. Electromagnetic interference, EMI, is defined as disruptive electromagnetic energy emitted by a device or system that can negatively affect the functioning of nearby electronic equipment. EMI can be intentional, as in the case of radio transmitters, or unintentional, as with the electromagnetic energy emitted by devices like mobile phones and microwaves. Unintentional EMI often leads to malfunctions or performance degradation in sensitive electronic equipment, necessitating various mitigation strategies to manage its impact. Components of EMC: emitter, receiver, and coupling path. In the context of electromagnetic compatibility, EMC, three key components are identified: the emitter, the receiver, and the coupling path. The emitter is any device that emits electromagnetic energy, either as part of its function or as a byproduct of its operation. The receiver is any device that may be adversely affected by this electromagnetic energy. The third component, the coupling path, refers to the medium or method through which the electromagnetic energy travels from the emitter to the receiver. Understanding these components is crucial for diagnosing and mitigating EMC issues, as it allows for targeted interventions at any stage of the electromagnetic interaction. This diagram illustrates the different types of electromagnetic coupling that can occur between an emitter, which generates electromagnetic energy, and a receiver, which is affected by this energy. Galvanic coupling. This occurs when the emitter and receiver are connected by a direct physical conductor. Electromagnetic energy is transferred through this direct contact, which can lead to interference if not properly managed. Inductive coupling. This type of coupling happens when there is a mutual inductance between the emitter and receiver. It's typically associated with magnetic fields that arise from current changes in the emitter, and then induce unintended currents in the receiver's circuits. Capacitive coupling. This happens when there is an electric field between two nearby conductors, in this case, parts of the emitter and receiver, causing a displacement current to flow through the space between them, which can introduce interference, especially at higher frequencies. Radiative coupling. Also known as electromagnetic or antenna coupling, this involves the transmission of electromagnetic energy through space from the emitter to the receiver. This can happen intentionally, as in radio communications, or unintentionally, leading to interference. Understanding these coupling mechanisms is crucial in the field of EMC for designing systems that can coexist without interference, or for diagnosing and solving EMC issues. Importance of regulations and standards. Regulations and standards in electromagnetic compatibility, EMC, play a crucial role in ensuring the safety and compatibility of electronic devices. They provide a framework that manufacturers must adhere to, ensuring that their products do not emit harmful levels of electromagnetic interference, EMI, and are immune enough to function properly in their intended electromagnetic environment. These standards, both international and national, serve as a common ground for manufacturers and consumers, providing assurance of product quality and safety across different markets. Compliance with these standards is not only a legal requirement in many cases, but also a benchmark for consumer trust and product reliability. Key international EMC standards. Several key international EMC standards are recognized globally, shaping the landscape of EMC compliance. The IEC 61000 series, established by the International Electrotechnical Commission, is a comprehensive set of standards covering various aspects of EMC. The EN 55000 series is a European standard that aligns with the IEC standards, but is tailored for the European market. In the USA, the Federal Communications Commission's FCC Part 15 governs the emissions of electronic devices. Additionally, CISPOR 25, also known as EN 55025, is specifically focused on the automotive industry, addressing the EMC requirements for vehicles and their components. These standards collectively ensure that devices adhere to strict EMC guidelines, promoting global interoperability and safety. EMC testing and certification. The process of EMC testing and certification involves a series of evaluations conducted to ensure that a product meets the relevant EMC standards. During this process, products undergo various tests to measure their electromagnetic emissions and immunity levels. Emission tests determine the amount of electromagnetic energy a device emits, while immunity tests assess how well the device can operate when exposed to external electromagnetic disturbances. Once a product successfully passes these tests, it can be certified, indicating its compliance with the specified standards. This certification is a vital step in the product development lifecycle, as it validates the product's conformity to international safety and performance standards, enabling its introduction to the market. Methods to ensure electromagnetic compatibility. EMC design considerations. In the realm of electromagnetic compatibility, EMC, key design considerations play a pivotal role in mitigating electromagnetic interference, EMI. Shielding involves the use of barriers, such as metallic enclosures or coatings, to attenuate electromagnetic fields and protect sensitive components from external EMI. Filtering is another critical strategy, where filters are applied to power and signal lines to limit the frequencies that can pass through, thereby reducing EMI. Proper grounding techniques are also essential. They help to stabilize the electrical system and dissipate unwanted electromagnetic energy, minimizing the potential for interference. These design elements are fundamental in creating electronic products that maintain functionality and compliance in electromagnetically diverse environments. EMC compliance in product development. Integrating EMC considerations early in the product development process is crucial for ensuring compliance and avoiding costly redesigns later. This proactive approach involves considering EMC requirements from the initial design stages and continuing through the entire development lifecycle. Iterative testing and modifications are key aspects of this process. Products should be regularly tested for EMC compliance during development, with adjustments made as needed based on test results. This iterative cycle helps in identifying potential EMC issues early and addressing them effectively, thereby streamlining the path to compliance and market readiness. Best practices for EMC. Implementing best practices for EMC involves a combination of technical strategies and organizational measures. Key among these is providing training and raising awareness among designers and engineers. This educational approach ensures that the personnel involved in product design and development are knowledgeable about EMC principles and their application. Additionally, conducting regular EMC audits and compliance checks is crucial for maintaining standards. These audits help in identifying any deviations from compliance norms and provide opportunities for corrective actions. Such practices not only ensure regulatory adherence, but also contribute to the overall quality and marketability of electronic products. Sources and effects of electromagnetic interference. Common EMI sources. Electromagnetic interference, EMI, can originate from a variety of sources, categorized broadly into natural, industrial, and household origins. Natural sources include phenomena like lightning and solar flares, which can generate significant electromagnetic disturbances. In industrial settings, sources of EMI often include motors, switches, and various electronic devices, all of which can emit electromagnetic noise during operation. Household sources are increasingly prevalent and include everyday devices such as wireless routers, microwaves, and mobile phones. These sources, though commonplace, can contribute to a crowded electromagnetic environment, leading to potential interference with other electronic devices. Effects of EMI on devices. The effects of electromagnetic interference, EMI, on electronic devices can range from minor annoyances to critical failures. One common impact is signal distortion or loss, which can interrupt communication signals in devices like radios and cell phones. In data-sensitive applications, EMI can lead to data corruption, exemplified by the malfunction of video signals where image quality is degraded or lost. More seriously, EMI can cause device malfunction or failure, which is particularly concerning in safety-critical systems such as avionics and navigation systems in aircraft. In these scenarios, EMI can disrupt the normal operation of instruments, posing significant risks. Real-world examples of EMI effects. EMI can have diverse and significant impacts in real-world scenarios. For instance, EMI from a household microwave might interfere with Wi-Fi signals, causing internet connectivity issues. In medical settings, EMI can affect the performance of sensitive equipment like MRI machines, potentially leading to diagnostic inaccuracies. In the automotive industry, EMI can disrupt the functioning of electronic control systems in vehicles, affecting everything from entertainment systems to crucial safety features. These examples underscore the importance of effective EMI management in ensuring the reliable operation of electronic systems across various domains. EMC testing and measurement techniques. Purpose of EMC testing. The primary purpose of electromagnetic compatibility, EMC testing, is to ensure that devices comply with specific EMC standards set by regulatory bodies. These standards are designed to guarantee that electronic devices are not emitting excessive electromagnetic interference, EMI, and are adequately immune to external electromagnetic disturbances. Another critical aspect of EMC testing is to identify potential EMI issues during the product development phase, before the product is released into the market. This proactive approach helps in avoiding costly post-market modifications and ensures that the product is both safe and functional in its intended electromagnetic environment. Common EMC tests. EMC testing encompasses various types of tests, with emission tests and immunity tests being among the most common. Emission tests involve measuring the electromagnetic emissions from a device to ensure they are within the limits set by EMC standards. These tests help in determining whether a device is likely to cause interference with other equipment. On the other hand, immunity tests assess a device's resistance or tolerance to external electromagnetic fields. The objective here is to ensure that the device can operate correctly and reliably when exposed to common sources of electromagnetic noise in its operating environment. Both types of tests are integral to achieving overall EMC compliance. EMC testing and measurement techniques. Measurement techniques. In EMC testing, various measurement techniques are employed to assess the electromagnetic compatibility of devices. Spectrum analyzers are crucial tools used to measure the frequency and amplitude of emissions from electronic devices. They help in identifying and quantifying electromagnetic emissions across a wide range of frequencies, thus ensuring that the device complies with emission standards. Anechoic chambers, another vital component in EMC testing, provide controlled environments that are free from external electromagnetic interference. These chambers are designed to absorb reflections of electromagnetic waves, making them ideal for accurately measuring the emissions and immunity characteristics of devices without external noise contamination. Case studies. EMC testing plays a significant role across different industries, ensuring product safety and regulatory compliance. In the telecommunications industry, EMC testing helps in mitigating interference among communication devices, enhancing the quality and reliability of connections. In the medical sector, EMC testing is crucial for the safe operation of sensitive medical equipment, ensuring that they are immune to electromagnetic disturbances, which could otherwise lead to incorrect diagnoses or malfunction. In the automotive industry, EMC testing ensures that the increasing number of electronic components in modern vehicles do not interfere with each other, thereby ensuring vehicle safety and functionality. These case studies highlight how EMC testing has been instrumental in improving product safety and ensuring compliance with international standards across various sectors. EMC compliance in global markets. EMC in consumer electronics. In the field of consumer electronics, electromagnetic compatibility, EMC, is critical to ensure that devices such as smartphones, computers, and home entertainment systems operate reliably without causing or suffering from electromagnetic interference. EMC in these devices not only guarantees their proper functioning, but also ensures that they do not adversely affect other electronic equipment in the vicinity. Moreover, with the growing reliance on wireless technology, managing EMC in consumer electronics has become even more crucial to prevent signal interference and ensure user safety. Global EMC standards and regulations. Navigating global EMC standards and regulations is a complex task for manufacturers of consumer electronics due to the variation in EMC standards across different regions like the EU, USA, and Asia. Each region has its own set of requirements and compliance procedures, making international compliance a challenging but essential aspect for global product distribution. Manufacturers must be vigilant in understanding and applying these diverse standards to ensure market access and avoid legal issues. Challenges in global compliance. One of the primary challenges in global EMC compliance is staying up to date with constantly evolving standards in different regions. Additionally, managing the certification process in multiple countries can be resource-intensive and complex, requiring a deep understanding of various regulatory environments. Keeping track of these changes and navigating the certification processes efficiently is crucial for timely and successful product launches in international markets. Strategies for global EMC compliance. To achieve global EMC compliance, a strategic approach is necessary. Developing products with the most stringent standards in mind can ensure broader compliance and reduce the need for region-specific modifications. Additionally, partnering with experienced compliance consultants can provide valuable insights and guidance, helping manufacturers navigate the complexities of global regulations efficiently. These consultants can offer up-to-date information, assist with testing and certification processes, and provide strategies to meet diverse regulatory requirements. Case examples. Companies that successfully navigate global EMC standards often serve as benchmarks in the industry. These companies manage to balance product design, functionality, and compliance, turning the challenge of EMC regulation into a competitive advantage. Lessons learned from these companies often highlight the importance of proactive compliance planning, the benefits of early and continuous testing throughout the product development cycle, and the value of expert consultation. These case examples provide practical insights and best practices that can be applied by other companies facing similar compliance challenges in international markets. Future trends in EMC. Advancements in technology, impact on EMC. The rapid advancements in technology, particularly in areas like 5G, the Internet of Things, IoT, and artificial intelligence, AI, present both challenges and opportunities for electromagnetic compatibility, EMC. The proliferation of 5G technology brings higher frequencies and more complex modulation schemes, posing new EMC challenges in terms of interference and signal integrity. IoT devices, due to their sheer number and variety, significantly increase the potential for electromagnetic interference in everyday environments. AI, particularly in its hardware implementations, requires careful EMC considerations to ensure data integrity and system reliability. These advancements, while pushing the boundaries of innovation, necessitate a re-evaluation and evolution of current EMC practices to address the emerging spectrum of electromagnetic challenges. Evolving EMC standards. As technology continues to advance at a rapid pace, EMC standards too must evolve to keep up with these changes. International standards organizations are continually working to anticipate and incorporate modifications in response to the introduction of new technologies like 5G, IoT, and AI. Staying ahead in compliance is crucial for manufacturers and developers, as it not only ensures adherence to legal requirements, but also enhances the reliability and marketability of their products. This proactive approach to compliance requires a keen understanding of both current standards and potential future changes, allowing for the design and development of products that are not only compliant today, but will remain so in the foreseeable future. Future of EMC testing. The future of EMC testing is poised to see significant innovations in both methods and equipment. As electronic devices become more sophisticated, traditional testing methods may no longer suffice, leading to the development of advanced testing techniques that can accurately assess EMC in complex environments. Predictive modeling and simulation are expected to play a crucial role in this evolution. These tools allow for the virtual assessment of a product's EMC performance, identifying potential issues before physical prototypes are even built. This shift towards simulation-based testing could significantly reduce development time and costs, while improving the accuracy and effectiveness of EMC assessments. As we move forward, these innovations in EMC testing will become increasingly important in ensuring the compatibility and safety of advanced electronic systems. EMC education and training. Importance of EMC education. Education in electromagnetic compatibility, EMC, is fundamental for building a strong foundational knowledge in EMC principles. Understanding EMC is crucial not only for engineers and technicians working directly in fields related to electronics and telecommunications, but also for a broader range of professionals whose work intersects with these areas. A solid grasp of EMC principles helps in comprehending how electromagnetic interference affects various devices and systems, and the ways to mitigate such issues. This knowledge is essential for designing, manufacturing, and maintaining reliable and safe electronic products and systems. Training for professionals. Professional training in EMC is vital for engineers and technicians who need to stay abreast of the latest developments and best practices in the field. Specialized courses and workshops provide in-depth knowledge and practical skills essential for tackling real-world EMC challenges. Certifications and qualifications in EMC, obtained through these courses, validate a professional's expertise and commitment to maintaining high standards in their work. These qualifications are often sought by employers and can be crucial for career advancement in industries where EMC is a key concern. Academic courses and research. Academic institutions play a significant role in EMC education through dedicated university courses and research programs. These courses provide students with theoretical knowledge and practical experience, preparing the next generation of engineers and researchers in the field. Furthermore, ongoing research and development in EMC at universities and research institutions contribute to advancing our understanding of electromagnetic phenomena and developing new methods and technologies for EMC management. Resources for continuous learning. Continuous learning is essential in the rapidly evolving field of EMC. Professionals can stay updated through various resources provided by professional bodies and associations dedicated to EMC. These organizations often host conferences, seminars, and workshops, offering opportunities for professionals to learn about the latest trends, share experiences, and network with peers. Additionally, a wealth of online resources, including webinars, online courses, and publications, are available, allowing professionals to further their knowledge and skills in EMC at their convenience. These resources are invaluable for staying informed and proficient in the ever-changing landscape of EMC.